All right, continuing on with 7-6, I want to do another example of graphing, this time graphing from a word problem. So it says computer mapping software allows you to zoom in or out on an area to view it in more detail. The function f of x equals 100 times 4 to the x models the percent of the original area of the map. The map shows after zooming out x times. So x is the number of times we've zoomed out. So then we're graphing the function. So we're given the function, we're going to graph it. So in a word problem situations, in the last video I said always make sure you have some negative numbers and some positive numbers. In a word problem situation, sometimes it doesn't make sense to have negative numbers. So in this situation, we're just going to use positive numbers. Sometimes you'll want to use negative numbers. It really just depends. So in this example, we're only using positive numbers. And so let's do this. So we're just using the function that they gave us. So we're plugging in x equals 0. 4 to the 0, right? Anything to the 0 is 1. So 4 to the 0 is 1. So 100 times 1 is going to be 100. 100. And then, so our point is going to be 0, 100. And then in our next one, we're going to have 100 times 4 to the 1. Well, 4 to the 1 is just 4. So we have 100 times 4 is 400. So our next point is 1 and 400. 1, 400. And then when x is 2, we're going to have 4 to the second power, or 4 squared. 4 squared is 16. So 4 times 4 is 16, right? So 100 times 16 is 1600, 1600. So our next point is 2 and 1600. And then when x is 3, we have 100 times 4 to the third power. So that's 100 times 4 to the third power is 64. So we have 100 times 64, so that's 6,400 or 6,400. So our point is going to be 3 and 6,400. And then our last point here is when x is 4, so we have 100 times 4 to the fourth power. 4 to the fourth power is 256. So this is 100 times 256. And then, so if we multiply those together, we get 25600 or 25,600. So our last point is going to be at 4 and 25,600. So graphing that, we start with x is 0, we're at 100. So when x is 0, we're at 100. This is scaled by 5,000, so this would be 2,050. So 100, compared to this scale, 100 is really small. So we're going to be way down here. 100 is really small. 400 is still really small. So over here at 1, we're just going to be a little bit higher. Then 1,600, remember I said this line, this line is going to be half of this line, so 2,500. So this is a little more than half of that. So I'm just going to over here at 2, I'm just going to approximate. It's going to be a little more than half, something like that. 3 at 6,400. 6,400 is going to be up here somewhere. This would be 7,500. So 6,400 is up here somewhere over here. X is 3. 6,400. And then 4 and 25,600. 4 is over here. X is 4. We're going to go up to 25,600. So we have a line for 25,000. So we're just going to be a little bit above that line. A little bit above that line. And so our graph is going to look like this. And this is going to be the same basic shape that all of these graphs are going to look like. All of these graphs are going to have this basic shape. So if your graph ends up having a different shape, then you might want to check your math over here because something isn't quite right. Because when we have an exponential, it should always be this shape. It might be facing a different direction, like it might go this way, right? It might go this way, off down here. But it's always going to be this basic shape. So that is a good self-check. If you're graphing and you get something that's not this shape, you might want to check your math. Also, when you're graphing, I'm pretty sure the homework doesn't give you a graph, so you're going to want to graph probably on a separate sheet of paper. You can download graphing paper off the internet and print it if you want. That's probably, or you can buy a graphing paper notebook. That would be the other way to do it. So either one of those things, but you're going to want to graph on a separate sheet of paper. All right. Let me know if you have any questions.